We live on a finite marble, a perfect sphere of scarcity and fierce competition.
We've spent centuries digging into its crust, exhausting deposits that took eons to form.
The demand for the critical elements that power our modern world is insatiable and accelerating.
But what if the solution to Earth's scarcity wasn't on Earth at all?
Out here, in the cold, chaotic expanse of the asteroid belt, are rocks holding more wealth than every nation on Earth combined.
These are the solar system's forgotten leftovers, the primordial building blocks that never quite made it into a planet.
A single, medium-sized platinum-rich asteroid can contain more PGMs than have ever been mined in human history.
We are facing a choice. Continue to fight over scraps on a shrinking planet, or look up.
But how do we get there? What would a universe of infinite resources actually look like?
This is the science of asteroid mining, not science fiction, but the inevitable next step for civilization. We must understand what we're looking for, where to find it, and the radical technologies needed to extract it. And the outcome is profound: the liberation of humanity from the constraints of the periodic table.
This is the beginning of a post-scarcity future. Welcome to the mining belt. Today, nearly all of our high-tech industry runs on a handful of rare earth elements.
Their terrestrial sources are geographically concentrated, creating complex geopolitical choke points and environmental nightmares.
The extraction process is notoriously dirty, contaminating groundwater and destroying delicate ecosystems. As we transition to electric cars and renewable energy, this bottleneck will only tighten. Our greatest challenge, climate change, is inextricably linked to our resource constraints.
The asteroids are a cosmic recycling bin of pure, pre-concentrated material.
Instead of mining rocks that are 0.001% metal, we can target rocks that are 10 to 20% pure nickel and iron. The sheer volume of structural material for building solar power satellites and orbital habitats is astronomical. Crucial insight: mining the elements in space to build in space. No need to lift material out of Earth's gravity well. Escaping Earth's gravity costs thousands of dollars per kilogram. The ultimate cosmic tariff. The first product of asteroid mining won't be platinum jewelry, but water. Water for orbital fuel and life support. Many C-type asteroids are like flying deep frozen sponges, holding vast reserves of H2O ice.
This space water is the cheapest, most effective propellant for deep space travel. With cheap fuel and building materials in space, the entire cosmic economy is unlocked.
It's the difference between a self-sustaining civilization and an outpost constantly supplied by Earth.
Asteroid mining is the lever we use to move the world, lowering the cost of everything off-world. But a problem emerges. If a single person can own $1 trillion rock, what does that do to the terrestrial economy? The influx of platinum won't crash the economy overnight. Platinum is too dense to be easily returned to Earth.
The vast majority of the mined wealth must stay in space, where its true value lies in building.
The core context is this: asteroid resources make possible a future where millions of people live off-world.
Space is not a lifeboat, but an infinite territory for expansion, a safety valve for our civilization.
Our resource scarcity is merely a lack of imagination, a failure to look beyond the gravity well. The technology for this new era is being developed right now,
driven by the lure of the void's ultimate treasure chest.
Space mining is simply the most efficient form of large-scale solar power utilization.
Our fate as a species is tied to what we can build, and what we can build is tied to these rocks.
Science begins with classification. About 75% of all asteroids are C-type, dark, and rich in volatiles.
This is the water and carbon source, the dirt that gives us life support, and the feedstock for plastic manufacturing.
The S-types are the most common after C, containing iron, nickel, and magnesium silicates.
Easy to process for structural metals, but their riches are diluted by large amounts of rock.
The rarest and most valuable are the M-types, the exposed cores of shattered, early solar system bodies.
The first rule of space mining is to move the mine to the refinery, not the product.
Lagrange points, gravitationally stable spots, are the perfect cosmic docks for processing massive objects.
The entire asteroid must be encapsulated to prevent fragments from drifting away and causing orbital hazards.
The core extraction process for volatile-rich asteroids is pyrolysis, simply baking the rock in a huge solar oven. In zero gravity, traditional separation methods fail. We must rely on electricity, magnetism, and vast temperature differences. For the metallic cores, we use liquid metal extraction, or carbonyl processes, to separate the platinum and gold.
These chemical hooks selectively bind to the target metals, pulling them out of the bulk material. The byproduct is not waste, but structural material for space colony shields, spun up and launched using electric mass drivers.
The mass driver is our zero-G locomotive, accelerating payloads to high velocity with electrical power. It's the ultimate closed-loop system. Solar energy mines the rock builds the infrastructure supports more mining.
Even the most fundamental resource, soil, can be produced by grinding and processing the asteroid's silicates. Humans are needed for maintenance, repair, and overall direction, the command and control, not the dirty work.
The biggest risk remains micrometeoroid impacts and solar radiation, the chaotic nature of the void.
Robust shielding and dynamic pathfinding algorithms are non-negotiable for long-term survival in the belt.
Self-healing structures and decentralized AI will be the key to managing a trillion-dollar asset thousands of kilometers away.
The numbers are so large they become meaningless. They represent not money, but the raw material for building a second civilization. This will not be a chaotic gold rush, but a highly regulated, internationally governed system, by necessity.
The legal framework for space ownership and resource rights is arguably the most complex engineering challenge of all.
The final product is a universe of metal and water, the fundamental ingredients for life and expansion. Transport logistics rely on high-volume, low-thrust propulsion, like solar electric or nuclear thermal rockets.
This slow, steady movement is efficient and cheap, perfect for non-perishable bulk construction materials.
The truly rare and small-volume platinum, however, might be brought back for high-value terrestrial manufacturing.
Even this requires immense care, as Earth's fragile environment must not become a dumping ground for space debris. Less than 0.1% of the material mined will ever return home, keeping the terrestrial market stable.
Space mining's ultimate goal is to create a closed loop, where resources are recirculated and reused indefinitely.
Every new refinery is a consumer, but also a producer of its own energy and future feedstock.
This mastery of local resources is the only way humanity can ever hope to become truly interstellar.
An interstellar probe requires resources to build, fuel to launch, and materials for its power source, all sourced beyond Earth.
Future projects might even involve self-replicating mining probes, programmed to build the next generation of infrastructure.
An evolving ecosystem of machines, working together to turn cosmic grit into civilization.
The key is tailoring the operation. A different drill for a carbonaceous sponge, a different furnace for a metallic heart.
The system must be robust enough to operate unattended for decades, only calling for human oversight in emergencies.
The physics of processing in microgravity must be mastered, from fluid dynamics to the behavior of superheated plasma.
This system, fueled by a star and built from the planetesimals, is the ultimate engine of expansion.
The human story of asteroid mining is the end of the resource curse. When key strategic resources are abundant in space, the pressure for terrestrial resource wars dissipates.
Nations shift from fighting over oil and gas to collaborating on billion-dollar orbital infrastructure projects.
The sheer volume of material ensures that Earth can transition to a fully circular, repair-based economy.
When structural metals and water are essentially free in space, the barriers to large-scale innovation disappear. This frees up the human economy to focus on non-material needs: education, art, science, and exploration.
But it's also a profound shift in our collective psyche, from a species confined to one well. Asteroid mining is the prerequisite for the greatest human migration in history.
This is not a struggle against nature, but a collaboration with physics to create new, stable homes.
These are truly new worlds, built by us, for us, to our specifications, not merely inherited.
The ecological impact on Earth is a net positive. We leave the terrestrial resources alone, allowing the planet to heal.
We transfer our appetite for digging to the non-living rocks of the void, sparing the biosphere.
The ethical consideration of protecting extraterrestrial life is also simpler. These rocks are barren. They are inert.
This is the Great Expansion, the moment when our civilization's material base matches its technological ambition.
We diversify the species' location, ensuring ourselves against a single catastrophic event on one planet.
Humanity has always faced existential risks, from ourselves, from nature, and from the cosmos.
Asteroid mining doesn't solve all our problems, but it solves the one that prevents us from reaching the next stage of civilization.
We become less fragile, less dependent, and more robust, a hedge against oblivion.
The emotional connection is simple. The profound feeling of being a builder rather than a taker.
It is the ultimate expression of human ingenuity, turning cold, dead rock into warmth and life.
The light we live under, the air we breathe, the ground we stand on, all products of our cosmic labor.
This is the legacy we can leave. Not a diminished, exhausted Earth, but a boundless, multi-world civilization.
A future where the limitations are not materials, but purely imagination.
This changes the nature of what a developed civilization even means.
The human connection to these rocks is our future, turning scarcity into abundance.
We began this story on a finite marble, bound by its physical limits and geological history.
But the Earth's limits are not our limits.
The asteroid belt is the great cosmic inheritance, our birthright to a universe of material wealth.
We merely had to learn how to open the box and master the gentle art of zero-G extraction.
Every drop of water, every kilogram of metal is now a statement of intent. We choose expansion over exhaustion.
This network is a living testament to our collaborative genius.
The work is never truly done, as every completed habitat demands the resources for the next.
It is a game of logistics, physics, and patience. a game played against the vastness of the cosmos.
The solar system is no longer a collection of separate worlds, but a single, integrated economic zone.
We have finally made peace with our scarcity by choosing to live in a universe of abundance.
Look up. The wealth of the cosmos is waiting. The only thing missing is us.
The age of the infinite has begun.
The question is no longer if we can do it, but what we will build once we have.
Think bigger.